Hello everyone, welcome to the second session of our digital logics and process. Last session we discussed about what is a microprocessor, what is a microcomputer, microcontroller, and how a general purpose system and an application system varies. Now today we'll talk about how the computer is actually organized and how they communicate with each other and how the components work with each other. So if you look at the categories of the entire computer, or if you can list down the components of your computer, there will be your CPU, your RAM, ROM, hard disk, keyboard, mouse, printers, etc. etc. If I look into the generalization of all this, these all will fall under the processing elements. Your RAM, ROM, hard disk, all these form under the memory elements. And your keyboards, mouses, all these forms under the inputs or outputs. So that is the easiest way you can categorize everything in your computer. So this is what the organization is showing: your processing elements, your memory elements, and your IO elements. And today we'll be discussing about how they are interconnected in your computer. They stay away, they stay in different parts, but do they need to communicate? Yes, because maybe your memory has your program which is to be executed in your CPU, or you type a program in your C where you want to take an input from a keyboard. So your program is in the memory which is being run by the CPU, which needs an input from a keyboard. You need to type a key, then only the CPU can take the data and process. That means there needs to be a communication system between all these things to work. So that something is called as a bus. So a bus is something which communicates the data from one peripheral to other peripheral. Like we said, input outputs are all the devices that you see in your computer. And the processing elements falls your CPUs, your graphic processors. And what it does, we have discussed in the last session. It has three parts: it has an ALU, it has a CU, and an internal registers and a memory unit, which will where the execution is done by the ALU, and what should be executed, what should be not, is controlled by the control unit, and the inputs and the results are stored in your memory unit. So it fetching is bringing the data, it brings the instructions from the memory, and it decodes. Okay, what is this guy talking about? Does he want to do addition? Does he want to do subtraction? Okay, I'll tell. That is what is decided by the control unit, and it will instruct the ALU. Okay, he wants to do the addition, let's do the addition for him, and then stores the data. It also contains addresses, counters, and some kind of registers where to get the data from, where to point the data from. So there will be a large program that is available. So where is my program available? I have to go locate it, I have to bring it, I have to store it. So that is part, that the organization of the data is done in the memories. You know that RAMs, ROMs, hard disks are the memories that are used to store your data. How is this actually the data is stored? Your data or your memory is nothing but array of registers. And what are registers? Like we said, registers are certain amount of containers, and each container has a size. Let's say I have a 8-bit register. That means each register you'll be able to store 8 bits of data. So this is register 1. Like that, how many registers I have? 1, 2, 3. So it has register 1, register 2, register 3, 4, 5, 6. So 6 registers of 8 bits of data each. And if I want to store the numbers, okay, I want to store 12 and 24. So 12 will be stored here, 24 will be stored here. And that's how the memory actually works. And how do you identify where the program is stored? Suppose you wrote a program called C is equal to 12 plus 24. So this 12, 24 and plus are somewhere stored in the memories. I have to go get the data now. How do I go get the data? There are thousands and thousands of registers in your computer. So how could I actually go there and get the data? Every register or every memory is identified by something called a address, and each address will have data inside it. That's how you identify something. That means how your computer stores your program, or when you write a program like C is equal to 12, this 12 is stored in certain memory location. Memory location itself means it's an address. So whenever a CPU is trying to execute a program, what it will do, it will go to the memory and finds its address and gets the data and then executes it. So this is how you can see how the data is stored. You can the minimum size of data is a bit. 8 bits will form a byte, and 1 byte, 1 kilobyte is 1024 bytes, 1 megabyte is 1024 kilobytes, and maybe today's we are storing the data in terabytes in your computers. So this is used to store the data, and this is how the program is stored. All the registers are available. Registers will contain data, and each register will have a address. So through this address and data, we will be able to figure out where to store our data and where we can bring out the data from. So who is doing this whole thing? This thing is done by our bus. That means let us take an example of a program called 2 plus 3. So these are stored in 3 blocks. Let's assume that. So CPU needs to bring the data. So where should I go and bring the data? I need to go to the memory. I need to bring in 2. I need to bring in 3. I need to bring in a plus. So how do I bring it? I bring it through 3 kinds of buses. How do I identify where is my 2? My 2 will have an address. My 3 will have an address. So first CPU will put the address on the address bus. So address bus will take me to this location. From this location, I'll pick the data and put it on the data bus. And data bus will bring me the data. That's how I'm going to get 2 first. So let us assume 100, 101, 102 are the addresses for 2, 3 data. So first 100 will be put in the address bus. I'll go here and get 2, which is the data. So 100 is on the address bus, 100 is on the address bus, 2 is on the data bus. And the next iteration, I'll put 101 on the address bus, I'll go here, I'll look for 3, and I'll bring 3 through the data bus, and also the plus. So who will understand the plus inside your CPU? Your control unit will understand he's talking about to do a addition. So he'll instruct the ALU, do the addition now. And 2 plus 3 is done, and the result 5 is stored in the registers inside the CPU. Now, do you want to really store the result in your memory as well? Maybe yes. Then I have to put this 5 again on the data bus, and the address to store the data, I want to store it at 102. Then the data called 5 and comes and stores in the memory. So what's happening through this process? The address bus is carrying your addresses, the data bus is carrying the data, and what is this control bus? The control bus will decide which direction the data should go. So a 2 can be coming from memory to CPU, 3 is coming from memory to CPU, whereas 5 is coming from CPU to memory. We usually call them read and write. So the way you bought 2 comma 3 is read, and the way you stored 5 is called as write. So if you are fetching the inputs, that is read. If you are storing back the inputs, you will tell it's a write. So to summarize, let's see what happens again. So there are 2, 3, and this is the program. So 2, 3 is available here. So first in the address bus, I'll put 100 and I'll go here and I'll tell that you read the data. The control bus will take a signal called read. Okay, then this 2 is put on to the data bus and the CPU will get 2. Where does the CPU store? In your ALU, CU and your registers. The 2 gets stored here and it will go again. What it will go? It will go to 101 and again it will give a signal called read and the 3 will be coming and storing on the data bus and is stored in the internal registers. Now the control unit will tell, okay, you have to do the addition now. So the registers will send the data here and 2 plus 3 is done and the result 5 is again stored back to the registers. Now again these registers will store the data called 5 here, but where should I send this 5? To an address called 102. Is it a read or write? You give a control called write. That's how the operations between your CPU entire thing will work through the buses. So bus not only interacts with memory, it also interacts with your input outputs. You maybe want to read the data from a keyboard or you want to send the data to your monitor. So all these things are nothing but read and write operations. So this is the thing done by your address, data and control bus. If you say my computer is a 64-bit computer, how much data will I process? My ALU is 64 bits. My registers are 64 bits. So my width of the data bus is also 64 bits. I should be able to carry 64 bits data, right? That's what a 60 data bus does. Control bus is very simple. It only does 4 operations: read, write, memory write, IO read and IO write. There is a significant thing regarding the address bus. Address bus need not be something related to the data. Address bus will tell you how many memory locations I can have. That means if you have an n-bit address bus, you can be able to access 2 power n locations. That means if you have a 2-bit address bus, you can access 2 power 2 locations. And what is the size of data at each location? Let's say each size of data is 1 byte. I can access 4 bytes of data. That means I can have 4 bytes of memory in my computer. If I take an example of 3, which is 8, and let's say each location, I can have 8 locations, 0, 1, 2, 3, 4, 5, 6, 7, and the width of the location is 1 byte. Now I can have 8 into 1 bytes of data. I can have 8 byte of memory now, so 8 byte. Imagine today's your computer can store up to 4 TBs, 8 TBs of data. That's how that is decided by the width of your computer. Or one best example, you have an SD card which is expandable up to 128 GB. Why can't it be expandable more than 128 GB? Is because the address bus can't go to that address. It only understands these number of addresses. So this is the introduction about the organization of your computer and how they interact with each other. Thank you very much.